6. Using the dialog box, navigate to the lib boost _regx mgw47-mt-1 underscore 55.a library, the release version of the library. Select the library and then click OK. The boost library files are typically located in the /base/lib directory. When you click OK, you see a dialog box that asks whether you want to keep this as a relative path. Remember, relative paths specify location using the current location as a starting point. The alternative is an absolute path, which specifies the locations based on the root directory of your hard drive. In most cases, absolute paths are less likely to get broken. 7. Click No. You see the absolute path for libboost _regx -mgw47-mt-1 library added to the file field of the Add Library dialog box. 8. Click OK. After you click OK, you see the absolute path for the library added to the linker settings as shown in Figure 5-2. Figure 5-2, add the library to the application. 9. Click the Search Directories tab. You see the 3 subtabs, Compiler, Linker, and Resource Compiler. 10. Click Add in the Compiler subtab. You see an Add Directory dialog box like the one shown in Figure 5-3. Figure 5-3, add appropriate search directories for boost header and library files. 11. Type the location of the boost header files in the directory field. As an alternative, you can click the Browse button to use a Browse for folder dialog box to find them. The files are normally located in the /boost. Hi, Ryan Lesniak. In the /boost include /boost-1_55 folder. 12. Click OK. You see the search folder added to the compiler tab as shown in Figure 5-4. Ryan Lesnick, I don't know why WYLL means. Jonathan Bahorkaz. This is C All-In-One For Dummies. This is 3rd edition. This is written by John Paul Mueller and Jeff Coxwell, and we're finishing it up. At least it seems that way. This is the last chapter of the last book, so we'll see. Okay, Figure 5-4. The Search Directories tab will display the search location for any compiler, linker, or resource compiler. That's there. Okay. Okay, 13. Click Add in the linker subtab. You see, another Add Directory dialog box referred to Figure 5-3. 14. Type the location of the boost library files in the directory field and then select OK. The boost library files are typically located in the /boost/lib directory. After you click OK, you see the directory added to the linker tab. 15. Click OK. The regx library is now ready for inclusion in your application. Oh. Grasshopper Plus says still can't even turn computer on. Oh, yeah, I hear you. Technology. Creating the regx code using a regular expression is relatively straightforward. All you do is create the expression and then use it with a function to perform specific kinds of pattern matches. The function you choose is important because each function performs the pattern matching differently. The regex example code in listing 5-1 demonstrates how to create a regular expression and then use it in two different ways to determine whether user input is correct. Here we go. It was a little too early for sharing that. I pretty much like to show the things I don't want to talk about all the way. Listing 3-5, performing matches and searches using regex. Hashtag include IOStream, hashtag include boost, regex.hpp. Using namespace standard, using namespace boost. Int main, obtain an input from the user. Char my number 80. Cout type a 3-digit number. Cn my number. Define the regular expression. Regex expression 0 to 9, 0 to 9, 0 to 9. Create a variable to hold the matches. C match matches. Perform a matching check. If regex match my number matches expression cout you typed matches in line. I'll cout not a 3-digit number in line. Perform a search check. If regex search my number matches expression, cout found matches in line. I'll cout no 3-digit number found in line. Return 0. In this case, the code begins by adding the proper heading regex.hpp and the proper namespace boost. In many cases, you can get by without doing much more than performing these two steps in your code. The first step in the code is to get some user input, even though the prompt tells the user to enter a 3-digit number. C++ doesn't enforce this requirement. The second step is to create the regular expression. What we need for this example is a set of 3 ranges from numbers for numbers. So that's where the straight braces and inside is 0 to 9, and then that happens 2 other times. Using ranges works well for a number of tasks, and you use them often when creating a regular expression. The third step is to perform the pattern match. The example uses regex_match, which performs a precise match, and regex_search, which looks for the right characters anywhere in the input. Both functions require 3 input values. The value you want to check, the output variable of type cmatch that tells where this match is found, and the regular expression. To see how this code works, you must perform a series of 3 tests. First, run the application and type 0 as the input. Naturally, typing 0 means that the code will fail, and you see this output. Not a 3-digit number, no 3-digit number found. Second, let's see a success. Run the application again and type 123 as the input. This time you see you typed 123, found 123. So far, there isn't much difference between the two functions, which is why you need the third test. Run the application a third time and type ABC123XYZ as the input. Now you see the difference between a match and a search. Now a 3-digit number found 123. This final test shows that the regex_search function finds the 3-digit value in the string. Obviously, the regex_search function is great when you need to locate information, but not good when you need to secure it. When you need a precise pattern match, use regex_match instead. Breaking strings into tokens using tokenizer. As humans, we view strings as a sentence or at least a phrase. Mixtures of words create meaning that we can see in a moment. Remember, computers, on the other hand, understand nothing. A computer can perform pattern matching and do math, but it can't understand Kipling. Read more about this fascinating author at http://en.wikipedia.org/wiki/Rudyard_Kipling. It's because of this lack of understanding that you must tokenize text for the computer. A computer can perform comparisons on individual tokens. Usually, usually single words or symbols, and create output based on those comparisons. The compiler you use relies on a tokenizer, an application component that breaks text into tokens. To turn the text you type into matching code, the computer can execute. However, the tokenizer appears in all sorts of applications. For example, when you perform a spelling check on a document, the word processing application breaks the text into individual words using a tokenizer, and then compares those words to the words in its internal dictionary. The tokens example in listing 5-2 shows a method for creating tokens from strings. This basic technique works with any phrase, string, or series of strings. You'll normally process the tokens once you finish creating them. Listing 5-2, creating tokens from strings. Not again. I need a way to be able to turn off this. I used to be able to do that. That was so much better. There should be a way I could just not green screen. Okay. I'm gonna have to close out this stream.